All right, so I'll just give us 1 minute to allow those of us trying to join to quickly join in. So once we hit 15 online participants, then we'll just kick off today's class. So let's just start with the summary of what we have learned so far. So far, since on Monday, we have looked at blockchain fundamentals. We have learned certain terminologies. Yesterday, we also looked at cryptography and IPFS. Now, we did some practicals. I would like to know if at this point everyone has figured out whatever issue they were having. So, if you're having any issue as of yesterday and it's still persistent to now, I think you can just drop a message on the group to identify yourself so we know how assistance can be given onto you. Right. Okay, then let's go ahead with today's class. Today we'll be looking at blockchain layers. Blockchain layers. And the objective for today, we are going to be understanding what blockchain layers are. We're going to look at layer one and two blockchain solutions. And then we'll look at blockchain optimistic and ZK, that's zero knowledge roll-up techniques. Please, I would like us to pay close attention to this class because yeah, you need to pay attention to really understand what all these objectives are and to gain a better understanding of them. Thank you. So, just a moment. Okay, so we have 15 people so far, and then we'll just go ahead with the classes. The class. Now, what are blockchain layers? They refer to the architectural approach that divides the functionality and operations of a blockchain network into different tiers or layer or levels, each serving specific purposes and functionalities. These layers help in organizing and enhancing the blockchain's capability, scalability, and flexibility. Now, when we're talking about layers, we're talking about levels within the blockchain. Now, what are these levels? These levels are, yeah, they're like that. What makes blockchain, right? So when we're talking about different layers within the blockchain, we are going to be understanding what these layers do and then the functionality. But then we need to understand that each layer has its own function and responsibility within the blockchain. And what did they all do different things? Each layer does different things. And we're going to be understanding what each of them does and how blockchain layer works. Now, please, I would like us to note in relating this to a real life scenario, blockchain layers are basically when you want to build a component or let's say a house, there are different layers to building that particular house. There's the foundational part where you lay the foundation to the house before you move on to the other things. Now, before you can actually put on the lintel to your house, you need that particular foundation to be solid and upright before you can do other things. So, in the context of blockchain, these layers work almost in the same way. There's like the fundamental infrastructure layer that is needed in blockchain. Now, once you have that fundamental infrastructure layer, you can now begin to build on top of that to have your blockchain fully ready. Now, we'll be looking at layer one and layer two today as part of the blockchain layers. We have layer one and then there's also layer two. Now, we need to understand that when we're discussing about layer one blockchain, it is the foundational protocol layer of a blockchain network. So every blockchain network that exists all have a layer one. Yeah. Now, what this does is it acts as the foundation, that is the fundamental infrastructure that is required for that blockchain. Every other layer is going to build on top of layer one. Now, this layer encompasses the primary infrastructure, our core functionality upon which the entire blockchain ecosystem operates. So everything that's going to go on within the blockchain is going to be built upon this layer one. Now, examples of layer one blockchains are Bitcoin, Ethereum, Bitcoin. Now, I'm sure by now we should all know Bitcoin, Ethereum. They're all examples of layer one blockchains. So we'll be looking at the key aspects of layer one blockchains. Most of the things we have taken a look at this past few days, they are actually part of the key aspects of layer one. That is the characteristics. We have looked at consensus mechanism, we have looked at security features, we have native tokens.
Once you deactivate the camera,
So please, can we mute? All right, thank you. Now, we're taking a look at some of this. We're going to just understand, taking a brief look at consensus mechanism again. You need to understand that at the heart of layer one is this consensus mechanism. So it detects how transactions are validated. I think we understood this yesterday. And then it also detects how transactions are added to the blockchain, how they are linked to the blockchain. Now, the second characteristic of layer one blockchain is what? Security features. So every security features are all characteristics of layer one. Okay. So layer one is responsible for establishing the security measures that makes the blockchain resistant to attacks. So we need to understand that layer one is responsible for the security features of a blockchain. And then we need to understand that and the security features includes the cryptographic hashes that we have talked about. It also includes this decentralized network and the yeah, and then transparency within the network. Another characteristic of layer one blockchain is native tokens. Some blockchains have native tokens, and token can actually serve different purposes within the network. What layer one does is it defines the rules for this token creation, for the distribution and management. So tokens within the blockchain, layer one actually helps in the token generation, I mean. Now we need to understand that smart contracts also and decentralization, they are all characteristics of layer one blockchains. So all of this, they are the fundamental foundation, they are the foundations that are required and yeah, and are the characteristics of layer one blockchain. So please, is there any question about layer one blockchain and the blockchain layer definition so far? I don't know if at this point we understand what the blockchain layer definition means. Yeah. Do you understand? Those of us physically, do you understand the blockchain layer? Okay, good. Please, those of us online, are there any questions on the blockchain layer and layer one blockchains? All right. So moving on, we'll be taking a look at layer two, and majority of this class is going to be based on layer two. As I've said before, layer one is the foundation. Every other layer is going to be built on top of layer one. Do we get? So layer two in blockchain technology refers to an additional protocol. So that is an additional protocol or framework that is built on top of the primary blockchain infrastructure. Now, please note when I refer to when I mention primary blockchain, those know I'm referring to layer one, right? So layer two are additional protocols or frameworks built on top of layer one, and they serve as a supplementary layer and aims to address the inherent limitations and scalability challenges of layer one blockchain. Now, when we are building, most times when you are building like the foundation or trying to build like a fundamental layer of something, there are certain things that may not be optimized for certain purposes, and there are things like there are protocols you can actually add to that in order to optimize that particular layer one to be better. So now this is what L2 does. What it does is it takes a look at the challenges and limitations of layer one. Because yeah, I remember the first class we talked about limitations of blockchain. So there are certain limitations that blockchain proposes. And what this layer two does is it takes a look at okay, the layer one, such as the consensus mechanisms where you have proof of work, proof of stake. You know, each of them they all have like a disadvantage, right? So they look at that and then they begin to look for solutions on how can we solve this? How can we make layer one scalable? How can we make the limitations that are inherent to layer one, how can we solve those particular issues? So that's the essence of layer two in blockchain. Do we get that? So Arbitrum is an L2 solution for scaling Ethereum. So in order to, so when we're talking about scale, we're talking about increasing the throughput of transactions. So what do I mean? So if I say I want to scale something, it means I want to increase probably to a global level or to a certain level. So for example, if I'm limited to so if a business is attending to just 10 customers, right? When we mention scale, okay, I want this business to scale. What that means is I want to start attending probably to 1,000 customers or 1,000,000 customers. Yeah, to just expand. Thank you. That's the word. So scale means to expand. So Arbitrum is an L2 solution for scaling Ethereum. That is to undo, and you know, if you want to undo more customers, you need to expand your infrastructure. Probably if you have just one delivery man, you need to employ more people or even more staff to undo that level of customers. So that's just what we mean by scaling Ethereum. Arbitrum is an L2 solution that helps to scale Ethereum. Now, what are the purpose of L2 scaling? for addressing the scalability challenges in blockchain. Then the role of layer 2 solutions. We also have enhancing transaction throughput and efficiency. Now, when we talk about transaction throughput, what we are talking about is the amount of transactions that can be handled by a certain, should we say, milestone? So it could be per second, it could be per minute, right? Yeah. So it refers to the number of transactions a blockchain can process within a given time frame. So if you want to calculate the number of transactions Ethereum can handle per second or per minute, that's what transaction throughput refers to. And then the efficiency. Okay. Please, I would also like us to note, for transaction throughput, there are different factors that can affect the transaction throughput. That is, there are different factors that can affect the number of transactions a blockchain can process per time frame. Some of these factors include the network latency, that is, network can impact the speed at which transactions are confirmed. We also have the consensus mechanism. For example, remember we said for proof of work, people have to solve puzzles and stuff to, yeah. So that also can affect the transaction throughput. There's also hardware and infrastructure. So we have different factors that can affect the transaction throughput of a blockchain. So please, I would like us to take note of that. So now we're going to be looking into L2 deeply, the types of L2. So we're going to be looking at four types of L2. We have the state channels, we have the plasma, we have the side chains, and we're going to be looking at roll-ups also. Now, for state channels, they enable off-chain direct transactions between two participants. The participant can execute a series of transactions off the main blockchain and only submit the final result to the blockchain. This helps reduce congestion and increase transaction throughput. Now, use cases include micropayments, gaming, and any use case where frequent transaction between a set of participants are required. Now, what state channels does is, for the popular blockchains that we have, for example, Bitcoin and Ethereum, there's a limit. The transaction throughput actually low. The number of transactions they can handle per second is actually low compared to our traditional Web2. For example, I think Visa can handle about 100,000 transactions per second. Is it per second or per minute? Right? But when we come to our layer 1 solutions, such as Ethereum and blockchain, per second is not even close to that number. I think Bitcoin is about 7 or 14 per second transaction they can handle per second. So now to scale that, and one thing is, okay, for example, Bitcoin has about 180 million users. Compare that against the throughput of, you understand it's actually very low. And most people's transaction will be delayed as a result. So that's why I say that certain people, whenever they make transactions, they're actually delayed. If you want your transaction to be processed faster, you need to pay higher transaction fees higher gas fee for your transaction to be processed faster. So what L2, this state channel, does is that it takes the transaction off chain. So what do you mean by off chain? That is, the transaction is now outside the blockchain. So it takes it off probably Bitcoin. No, Bitcoin is the blockchain itself. So what state channel does is that it takes the transaction off the chain, and then since it's off the chain, it can now help to reduce the congestion. Since there are about thousands or millions of people trying to transact on Bitcoin, so it's going to reduce the congestion on the blockchain. And then it can also, because of the technology involved in the L2, since it's a solution built on top of the L1, it can increase the transaction throughput of the blockchain also. Now, we need to also understand that it's between two participants, that is user A and user B. And once the transaction is done off the main blockchain, it will now be added, the final result will be added to the main blockchain. So it is basically the transactions are taken off the blockchain. Once the transactions are done, the result is now going to be added back to the main blockchain. So instead of probably the blockchain handling countless number of transactions, it will be done off chain, and then that batch of transactions, once it's done, it will now be added back to the blockchain. So that's what state channel does, and then it's used where frequent transactions between a set of participants are required. So probably a group of people, the frequent their transactions are quite frequent. These state channels are usually used. Now, any question on that? So let's just proceed. If there's any question, you can just, probably when we're done, we'll understand it better. Now, the second type of L2 are side chains. These are they are independent blockchains that are interoperable with the main blockchain. Now, what do you mean? That is, they are linked to the main blockchain. They allow users to transfer assets from the main chain to the side chain, and then conduct transactions within the side chain, and then move the updated assets back to the main chain. So it is used for scalability and experimentation with new features without affecting the main blockchain. Now, I think using this is quite explanatory. We need to understand that, okay, if you want to, for these side chains, what happens is that it actually you can move your assets. Assets could be in form of your tokens, your NFTs. So you can move your assets from the main chain to the side chain, right? And then from your side chain, you can have decided to perform transactions there. So you can conduct transactions from your side chain. And then whenever you are done and ready, you can now move to back to the main chain. So do we understand sidechain and state channels at this particular point? Yeah. No, Arbitrum so Arbitrum is not an example of a sidechain. It's an example of roll-up, which we are going to see or understand later. An example of sidechains are Polygon. How many of us have heard of Polygon or worked around Polygon? Yeah. So Polygon is an example of sidechains. Yeah. Now, the next type is Plasma. So just add these statements. Sidechains they run parallel. Yeah, sorry, just a minute. Okay. So as I was trying to say, they actually operate in a parallel way compared to the main chain. That is, they are independent. All right. So far, any question? Let me just check the online chat if there are any questions so far. All right. So our moderator even helped us with the statistics. The Ethereum blockchain only allows about 20 to 40 transactions per second. That is the throughput. Meanwhile, Arbitrum can handle up to 40,000 transactions per second. So you can see how that helps to scale Ethereum. So that was one of the statistics. That's the power of scaling according to our moderator. All right, good. Please our moderator has a contribution, so I'll just give him the mic to speak to us.
Okay, thank you very much, King. So my contribution is that if you see blockchain as a computer, then you should look at layer one as the main processor, then layer two as an extension of that processor. So it's like having, also you can also picture it like this. If you have a system with 500 gigabyte of storage, but after some time you notice that you're about to exhaust that storage, then you buy an external slot to plug into the system so that you can have access to like 10 terabytes or more than that. So that's what layer 2 is all about. So layer 2 is just for scaling the main layer 1 blockchain. And one thing is that layer 2 cannot function without layer 1. So they work hand in hand. So layer 2 depends on layer 1 for security and other stuff. Then another thing about layer 2 and state channel is that you can also picture it like this. Instead of using your bank app every time, let's assume you want to send $1, or let me say you want to send $5. Then sending $5 on Ethereum at times you will spend more than um, more than the amount you're even trying to send as gas fee. So if you want to send $5 now, and the Ethereum network is asking you to pay $20 for gas fee, it should be, discouraging, and most people just be like, I'm not even interested in using blockchain or transferring through the network. So that's when layer 2 comes in. Instead of relying solely on layer 1 to send your transaction, which can be expensive, you can move some of your transaction to layer 2, which offers lower gas fee. So instead of using $10, $5, $20 to send little amount of money, you can move it to layer 2 and you spend less than a cent. Like instead of sending for $20, $30, $50, you can perform transactions on layer 2 with half a dollar, with 1 cent, 2 cents, depending on the kind of layer 2 solution you are using. Another thing about layer 2 again that we need to know is that layer 2 are very, very, they offer scaling solution in the sense that on the normal Ethereum blockchain, we have about 20 to 40 transactions per second. But when you look at the Arbitrum blockchain, it can handle 40,000 transactions per second. So more people can transact at the same time without worry of congesting the network. So that's what layer 2 is all about. And as we mentioned yesterday, that you guys should research some of the limitations of blockchain and how you would address it. This is just like a prerequisite to this morning class. And one of the problems with blockchain is scalability, meaning blockchain have limited power, limited processing power. So you to solve this problem, we are using a layer 2 solution. So that's what it's all about. And if you have any question, please feel free to drop it in the
It seems
comment
like you
box.
keep breaking. I don't know if it's just here.
Okay, can you guys hear me very well?
Can we all hear? Can we all hear him, please?
Oh, they can hear me very well online. I think it's maybe the network. But at least been able to get one or two things from what I just said. So that's all for now. Thank you.
All right. Thank you, Mr. Oracle, for that. I believe with that contribution, we have a better understanding of layer 2 and layer 1 solutions. Please, if you have any question, you can drop it on the group chat, via the group chat. Okay, moving on. Another type of L2 solution we'll be looking at is Plasma. Actually, not sidechain. Now, what are Plasma? Plasma is a framework that allows the creation of tree structures of blockchain. Um, so it is actually designed to improve scalability also, and then to reduce transaction costs. So just like our moderator have said, most of these solutions actually help in reducing transaction costs, that is in terms of gas fee, and then they also help in scalability. So Plasma is one layer 2 scaling solution that does that also. So what it does is that it creates side chains that are known as child chains in a tree kind of structure. We have the primary blockchain. Yeah, so the root chain is going to be the primary blockchain. Now, when you view a tree, we know we all have the roots. So now the root is the primary blockchain, that is the layer 1 solution. Now, on top of that, everything is connected to the root, and the root is like the source. So the primary blockchain is the root, that is like the source, and then you now have child chains around it, which is known as plasma chain also. So the plasma chain are child chains, and then each plasma chain can have its own set of rules and consensus mechanism. Each of these, and then they also provide scalability while being anchored to the security of the main chain. Now, they are all connected to the root chain. And as a result of that, they're benefiting from the security of the main chain. Now, it is used for building scalable decentralized applications and improved transaction throughput. So just from like a picture of a tree in your mind, and you understand the plasma, the root is the primary blockchain, which is the layer 1 blockchain. And then around it, we have the child chains, which is known as the plasma chain. Now, each of these plasma chain has its own set of rules. So it is independent and it can set its own rules, and also the consensus mechanisms involved that it wants to use. Now, these side chains can also process transactions more efficiently and quickly than the main chain. Since they have the liberty to set their own rules, they have the liberty to also process transactions more efficiently and quickly, even more than the main chain. Now, I also want us to understand that Plasma uses a mechanism called fraud proof. So what does this fraud proof does? So users can submit proofs of a fraudulent behavior that happened on the main chain. They can submit it to the root chain. So for example, now this child chain, since they have the liberty to process transactions and set their own rules and stuff. So in the case of fraud, now in Plasma, what happens is users can go ahead to report such fraudulent behavior or activities to the root chain. And then from there, the root chain can now take it up and see if it's true or not. So this ensures the security of funds, even when most transactions occur off-chain. So there are certain people that may be conscious of security. Is Plasma secure enough? Since we know, okay, the main chains have a high level of security, how can we be sure that this child chain also can ensure that the security is also tight? So now, using this fraud proof where you can report fraudulent behaviors and activities, the security here can be ensured. All right. Any questions so far on it? Let me check the chat. Are there any questions? Okay. No questions so far. All right. So now we'll be moving on to Rollup. And Rollup is one of the popular solutions. Arbitrum makes use of Rollup. So I would like us to understand and pay close attention to rollups. So now, rollups are a category of layer 2 solutions that bundle and roll up multiple transactions into a single batch, which is then submitted to the main chain. This reduces the load on the main chain and improves scalability. How does rollup work? Just like the word sounds, roll up. So it takes up multiple transactions and then it bundles it. So it takes up so it bundles the multiple transactions and then it just rolls it up. No, when you try to bundle, you can roll it up. So it will roll it up into one single batch, and then that single batch can now be added back to the main primary blockchain. So that's how roll-ups work, and that's the use of roll-up. Right. Now, we'll be looking at the types of roll-ups. There are two types. There's the optimistic, and then there's the ZK roll-ups. ZK as in zero knowledge proofs. So that's ZK. Yeah. Now, in understanding optimistic roll-ups, they operate on the principle of optimistic execution. What does optimistic execution mean? It's more like you assume. So you are optimistic that some probably a good thing will happen. So in terms of optimistic roll-ups, so they operate on the principle that okay, these transactions are valid. So when we are submitting them back to the main chain, you should just assume that okay, these transactions are valid, and then it go ahead, then you can go ahead to submit it. Now, transactions are initially processed off chain and then submitted to the main chain along with the cryptographic proof. The main chain assumes the validity of the submitted transactions, but allow. So we need to understand that when we're submitting the transaction back to the main chain, what the main chain does is it assumes that okay, these transactions that I'm submitting, they are valid. So it's more like it trusts the so just like okay, a boss and an employer and his employee. An employee comes back to submit reports, but then the employer looks at it. It doesn't bother to validate whether the report is correct because why? It feels it's going to be correct. It's optimistic that the report is going to be correct, and then it just gets to accept it. So that's how optimistic roll-up works. So it just assumes that okay, these submitted transactions they are valid, and then it gets added. But the security feature here that handles fraudulent activity is that users now can now decide so users can challenge any fraudulent activity by submitting proof. So in the case where it assumes that okay, these transactions are valid, but then it's not valid, the user involved now can decide to come in and then challenge that particular transaction by submitting proof that okay, this is a fraudulent activity. And then this roll-up actually has protocols and mechanisms in place in order um, for such transactions. So what actually happens if you actually want to understand is that what the main chain does is that it tries to replicate the transaction. So if you probably perform a transaction, it tries to replicate it on the main chain, and then once it notices using the security measures already in place on the main chain, to try to replicate that transaction, and then once it sees that this transaction isn't valid, it then flags it off. It then flags it up, and then most times, most of these chains attached to it, they actually have bond, which are already tied to the main chain. So in case like that, your bond gets seized or slashed. Now, Arbitrum processes Ethereum transactions through this method. So we need to understand that Arbitrum makes use of rollup, and in particular, they make use of the optimistic rollup, which is a case where the main chain assumes the validity of the submitted transactions. So that's optimistic rollup. What are the pros and the cons? What are the advantages and disadvantages of optimistic rollups? The first one is lower on on-chain fees. That is, you get to pay more, you get to pay less fees compared to how you would do normally. And then faster transaction confirmation. Now, what do we mean by faster transaction confirmation? Ideally, it will take more time for an employer to go through the report and confirm that the report is valid compared to when it's assuming. If you're assuming that, okay, this transaction is valid, it automatically means you're approving it, you're going to approve of it immediately. They'll be like, okay, you're done, it's stamped. So that's what happens. So using optimistic rollups, transactions are faster since it's assuming and doesn't have to go through any process of checking the validity of the transaction. Now, what are the disadvantages? The disadvantage is potential for fraud, but that can be resolved through dispute resolution. And then we have longer withdrawal times in case of a dispute. Now, whenever a user reports the transaction, nobody can access the funds at that particular point. And then till the dispute is resolved, you won't be able to withdraw. So that's a disadvantage. These are the disadvantages of optimistic rollups. The second type of rollup we're looking at is zero knowledge rollup. Now, zero knowledge rollups uses zero knowledge proofs to bundle and submit batches of transactions to the main chain. Now, zero knowledge proofs provide a cryptographic method to prove the validity of transactions without revealing the actual transaction details. This ensures security and privacy. Now, to understand this zero knowledge itself is a method. So it's a method of proving something without revealing the actual knowledge. So what do I mean by that? For example, I come to a friend and then I tell my friend in particular that, okay, I know your password, but I can't reveal your password to you. And then I go through some certain steps where I can now prove that I actually know the password in such a way that I don't actually reveal the password itself. So I'm sure there are certain scenarios where we might have done that. So for example, probably, how can I prove that I know the password to his phone without revealing the password itself? It probably gives me my phone and then tells me I should make a call. Then I can just decide to just input the password privately. And then operating the phone, you understand that yes, you actually know his password. But then at that particular point, you have not reviewed the particular password itself. So that's how zero knowledge works. You can actually prove the validity of transactions without revealing the transaction details itself. And this way, even in the presence of a third party, even if somebody is trying to eavesdrop on you, trying to hear your conversation, he won't still know the password, even though you can prove that you know the password. So that's how zero knowledge rollups work, where you can prove the validity of transactions without revealing the actual transaction details. So now, this actually helps in security because before each transaction can be validated, it has to go through this method, this cryptographic method. And then it also ensures privacy because most of the transactions that goes on through this zero knowledge, they are actually not public. They can be private, and then so some people actually make use of this because the transactions that zero knowledge rollups use, they can be private and not be opened to the public, just like the on-chain blockchain transactions. So now, what are the advantages and disadvantages? The pros are it's enhanced security, then privacy preserving. As I've said, transactions can be private, and then shorter withdrawal times. So now, what do you mean by shorter withdrawal times? In case of optimistic, because of dispute, it can take longer. But then, yes, since the transactions actually go through a process before they are validated, you can actually withdraw your funds in a shorter time. Now, the disadvantage is the higher computational cost for generating zero knowledge proofs. So because of the cryptographic method, it actually takes more computational costs. What do you mean by computational costs? That is more hardware, computer hardware, and then it's actually expensive to set up. You need like a high-end hardware and software to generate the zero knowledge proofs. So that's the disadvantage. Now we'll be looking at the differences between optimistic and ZK rollups, that is zero knowledge rollups. The first one is the execution and verification. The off-chain execution, for optimistic, off-chain execution with on-chain dispute resolution. I've explained this where in case of fraudulent activities, you can submit those activities to the on-chain, and then the on-chain will resolve the dispute. And then for ZK rollups, off-chain execution with on-chain verification using zero knowledge proofs. So the primary blockchain would actually verify using zero knowledge proofs. For security model, optimistic assumption with dispute resolution on the main chain, which is, well, I'll explain that also. For ZK rollups, security relies on zero knowledge proofs. For data availability, it is off-chain, requires access for dispute resolution. So whenever the on-chain wants to resolve a dispute, it actually it needs access to the off-chain because that's where the data is available. Data won't be available, and that's that for optimistic. For ZK, the transaction data included in the zero knowledge proofs for on-chain verification. So the transaction data, instead of going to the off-chain to access the data, is going to be included in the proofs that is being sent to the on-chain. And then we also have privacy. We have limited privacy additional measures needed for optimistic rollups. And then for ZK rollups, it provides higher privacy with zero knowledge proofs. As I've said, the transactions can be private if you want. And then, yeah, so that's it for privacy. And lastly, gas, in terms of gas fee and throughput. For optimistic, we have lower on-chain gas fee, improved throughput, that is improved transactions per second. For ZK rollups, we also have reduced on-chain gas fee. And then cryptographic overhead for proofs may impact off-chain costs. Now, remember we said for ZK, the computational costs may be high. So that itself might actually affect the off-chain costs. So it could affect it. Yeah. So basically that's it for optimistic and ZK rollups. And that's what we're going to, that will be all for blockchain layers today. Now, please, do you have any question so far? All right, so let's check our chat. So please, yeah, if you have any contribution or question, you can go ahead to raise your hand up and add for everyone to learn.
Okay. Yeah. Thank you so much, King, for the wonderful session. So I would just like to explain this concept of blockchain layer from another perspective, because yeah, most people when they hear about blockchain and the blockchain layer, they always get confused when it's too technical. So let's look at it from layman's perspective. So let's assume that blockchain is like a normal bank, and there are times whereby the bank is always congested. If you go on a Monday morning, it's always congested. Then maybe towards the end of the week again, people are just trying to make sure that they have enough cash for the weekend. So we always expect congestion when you walk into the bank physically. So now that's just what layer one is all about. Layer one blockchains, they always get congested when people try to send maybe funds and stuff like that, deploy smart contracts. So to solve that problem, we have layer two blockchain solution coming up, to propose different approach. You have different approach. Now, one of the approach we have is okay. Let's look at it from the normal traditional way. One of the ways can really solve congestion is that maybe in this our local government, instead of everyone going to the bank to make deposit, you can just contribute all the money to someone, and the person walk into the bank and the person settles all the transaction. Instead of having like 2,000 people walking to the bank, someone from a local government can just represent us and make the deposits. Then once the deposit has been confirmed by the bank, which is layer one, then we get an acknowledgement that okay, it has been confirmed. They can We can get feedback in real time that okay, this transaction has been confirmed. But one thing about layer two blockchain is that how do we trust the person submitting the transaction? What if the person is lying? What if the person didn't actually make the transaction? So that's when all these fraud proof, all these transaction delay period and all those stuff come in. So that's why it takes time for layer two blockchain to settle their transaction finally on L1. Is there light? Yeah, sorry, we lost connection locally. Can you guys still hear me? Oh, okay. So let's hold on for 2, 3 minutes. Okay, we are back on. Let's hold on for the instructor to join us. Yeah, King, once you're connected, let me know so that I can continue. Okay, we are back. Sorry for the interruption. So let me just continue from the state channel, since you guys have a layman understanding of the layer 2 blockchain solution. So for the state channel, so in state channel, you execute series of transaction between participants, and you submit the final result to the blockchain. Let's just picture it like this. You want to um, maybe buy stuff from a local store. Instead of sending it to them via the bank app, you can just pay them in cash. Then someone else walks in, pay in cash. Someone else walks in, pay in cash. You guys transact using cash. You're not using the
Sorry,
bank
no,
app. Can you hear me very well?
here is better now.
Okay. So instead of using the bank app to prevent congestion, you guys are just transacting using cash. You are paying using cash. Then at the end of the day, the supermarket will now be the one to submit the whole transaction to the bank so that they can have an updated state of the state channels. So that's how it works for the state channel. That's one kind of approach. Then for the side channel, you can't hear me, but it's cracking, right? Oh, sorry. So let's continue. Another thing again is that the the side channel is also an independent blockchain, and it allows users to transfer assets from the main chain to the side chain, and that one is just basically used for experimentation and scalability. So we can test functionalities on the side channel. It will not affect um, the main blockchain. Then the next thing about the other layer two solution is rollups, which is what we'll be dealing with throughout this program, because Arbitrum is a rollup solution. Then one thing about rollup is that rollup bundles transaction and submit it to the main chain. So it helps in offloading some transactions. Instead of having 40,000 transactions on the main chain, you can just have like one or two just to submit and verify the transaction on main chain. So we have different types of roll-up. King already explained that before, that in optimistic roll-up, you believe that, okay, this thing is valid until someone challenges that transaction. So it's going to be valid forever. And in our next class, we also look at how this is done and some kind of technology that has been adopted so far. Then for the ZK rollups, ZK is a bit technical, and it's still like most people are still trying to develop in that area. But one thing you have to know about ZK is that most ZK solutions now they don't allow you to execute smart contracts. They don't, most of them don't allow you. There are some that allow here because research upon research, we've been able to bring new solutions into the blockchain ecosystem. So, but for the roll up, optimistic roll up, you can deploy smart contracts, you can send transactions and every other thing. So that's one of the difference between ZK and optimistic rollup. And that difference is that in ZK, you can just see ZK like, okay, how can someone prove that they know the recipe? How can someone prove that they know Coca-Cola's recipe? The only way they can prove they know Coca-Cola's recipe is by showing you the list of ingredients and mixing it in front of you. And when you taste it, you feel like, oh, this is actually Coca-Cola. But there's another way we can do that in such a way that you will not leak the ingredients that makes up the whole Coca-Cola drink. So the only way you can do that is by saying, okay, let me just show you white labels. Then I will mix all these white labels together. And at the end of the day, if it tastes like Coca-Cola, that means I actually know the recipe for Coca-Cola. So that's how ZK works. So ZK works by showing you without revealing the real information behind that particular um, transaction. So it just say, okay, there's a transaction taking place, but you might not be able to see the full information regarding that transaction. Another thing again you have to know about ZK is that it's always very difficult to track ZK transaction from beginning to the end. So you might not be able to track it from the beginning to the end. So that's one of the main differences between both um, roll-up techniques. So if you have any question, please drop it. Trust, you have a question, you can unmute and ask the tutor so that he can answer your question. Yeah,
Can
trust,
you
you
hear me?
can. Yeah.
Hello, can you hear me? Hello.
Yeah, we can hear you, but if you can just come a bit closer to your mic.
Okay. I wanted to ask if you can throw more light on. I think I've heard of a layer zero before. I think I've come across a layer zero in my like in process of going through online materials and stuff. And I think I've also heard of some one Validium. Validium. I think maybe it's another type of layer two or something. But I think I've heard about Validium when I was going through I think a documentary on Matic. Polygomatic about their new upgrade. I think I heard about Validium, something like that. If you can throw more light on those two aspects for me, so I can uh, get a, I can comprehend it.
Okay, so let me just put like this. This question is beyond the scope of this class, but I will do my best to answer the question. So let me just answer you regarding layer zero. We also have other layers like layer three, four, yeah, as many as you want. But this course is just to focus. The focus of this course is on layer one and layer two. So for layer zero is a protocol to enable different layer one blockchain to communicate together. So that's what layer zero is all about. Then for the Validium, it's a protocol for validating the blockchain. So that's what Validium is all about. So I hope I was able to answer your question um, correctly. Yeah.
I don't know if you can like compare Validium and Rollup. Like, if maybe you can throw more insights that too, so that I can get a better comprehension. I know that you said it's a protocol for validation, like a ZK Rollup student, right? Hello, hello.
Yes, I'm with you. I'm with you. Okay,
Like,
so I'm going to be sending a link to you after this call. You can read more on that. So Validem is also a scaling solution that uses off-chain data availability and computation to design to improve throughputs um, of transactions. So it's just another layer two solution that you can it's basically it's like ZK rollup. So that's what Validem is all about. And another thing again is that it's controlled by a smart contract. So and just like ZK, it also allows you to confirm transactions and make instant withdrawals, near instant withdrawals. So that's what Validem is all about. But it's actually beyond the scope of this class, and I'm going to be sending you resources that you can check up online to read more about that if you are really interested in learning about validation. But it's beyond the scope of this class. And the scope of this class is optimistic roll up and how it's in peculiar Arbitrum blockchain. So if you need to read up on other solutions for layer 2, I can always make those resources available for you. Thank you.
Okay, thank you.
Any other question from anyone? Yeah, Kenny Black, you can unmute.
Hello, please can you talk more about the primary function of protocol in blockchain technology?
Sorry, I didn't get that question. Can you repeat it?
Hello, I said can you like about the primary function of protocol layer in blockchain technology?
The protocol layer.
Yeah,
Okay, yeah, King, can you take that question, please?
Sorry, I didn't get the question. Okay, bro.
Okay, was asking about protocol layer in blockchain.
reducing. Oh, yeah.
Oh, okay. Okay, so the protocol layer in blockchain, it refers to like the set of rules within the architecture of the overall architecture of blockchain system. That is, for every blockchain system that we have, there are like set of rules that have to that each probably transactions or each actions taking place within the blockchain. There are certain rules that have to be followed before such can be completed. So it's just like the set of rules or like a distinct level within the overall architecture of a blockchain system. Yeah.
Thank you.
Okay. Any other question before we call it a day?
Hello, please I want to ask,
Hello.
how does a decentralized identity layer enhance privacy and security in blockchain networks? And what are the key considerations in implementing such a layer?
Yeah, okay, King. Will you take that question?
Okay. How does a decentralized identity layer enhance privacy and security in blockchain?
Yeah, King, are you there?
Yes, I'm here. Okay.
Okay. Uh, you asked a question about identity layer in blockchain and how does it improve the blockchain security.
Oh, okay. Actually,
Sorry, King, we can't hear you. Are you saying something? Okay, let me just take the question. Hello, King, are you there?
yeah. So please, can you take the question? Like, can you just answer it?
Okay, okay.
Okay.
Okay,
Okay.
so in terms of identity management in blockchain, there are a lot of solutions already trying to integrate with a traditional KYC system, whereby you can use blockchain to perform KYC and also store and retrieve KYC data. Most of these solutions they use ZK, zero knowledge, so you don't need to really review the identity of people doing the KYC. You just need to tell them that, oh, okay, this is a real person. We have proof of humanity. Yeah. Hello, can you hear me? Okay, I was talking about there are a lot of blockchain protocols already working in that field. We have proof of humanity. We have some third-party solutions um, using blockchain for KYC, using yeah. I'm back. Can you hear me now? If you can hear me, you can just send an emoji so that I can continue. Okay, so as I've mentioned before, there are a lot of blockchain protocols adopting ZK to ensure that they don't review user information when they are through the process of KYC. And this is going to really help blockchain because it's going to prevent scamming, it's going to prevent hacking and the likes. So in case let's assume that okay, someone should scam you, you can easily track the person um, based on their credentials on the blockchain. But there are a lot of people that are not in this kind of technology because they believe blockchain should remain anonymous, that everything I'm doing on blockchain should remain anonymous. So these are one of the benefit of using blockchain for identity management and stuff like that. Yeah. I hope I was able to answer the question.
Thank you so much.
Yeah, welcome. That question. Yeah, Kenny Black can unmute.
Hello, sir. About our assignments, can you please make a short video on how we can submit on that
Yes, sir.
notion? Because I can't use that notion
Wait, is
properly.
it same as mine?
Okay, yeah. On the first video, we 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 showed how to do that. It's not so too complex. Just click on the um, assignment page, then add your name, then the URL to your assignment, and that's all. You
Okay,
can check the
thank
first
you.
video. The link is
Okay,
on the Notion wall.
okay, I will.
Okay, so sorry, I lost network again. You can submit via your social media accounts, can submit via YouTube. Just make sure it's a video and we can access it publicly. Yeah, that's all. Yes, you can use Google Drive. You can use Google Drive. That's still awesome. Any other question? Any other question? So just make sure that the Google Drive link is publicly available. Any other question before we call it a day? Okay. Is it a live video or like PowerPoint? It's a video. Just you can use your phone camera to record yourself for 2 minutes. Yeah, and explain. Let me check. I want to be very sure. Okay. Okay. Create a 2 minute video discussing the current challenges faced by layer one and layer two blockchain solution. So that's it. But to be creative, you can make it publicly available and tag Blockchain Innovation Hub so that we can retweet and see it in real time. Yeah. Any other question? Okay, Kenny Black can unmute. Kenny Black, you can unmute.
It's a mistake. I didn't drop my hand.
Okay, yeah. Ade Oniye, you can unmute.
Okay, thank you. Sorry, my concern is for the video. Is it that we just like we like a video where I'm just talking about the layer one and layer two, and just talking about whatever I need to talk about in 2 minutes, or are we like presenting like I don't know? Like I want to understand. Is it like we're doing like a screen record and probably like presenting something via the video or what? or I'm just talking?
You have to record yourself showing your face talking about layer 1 and layer 2 blockchain solution. Yeah. So that's it. Challenges faced by layer 1 and layer 2 solutions.
I think you
Record
can check
yourself.
out the Loom software.
Yeah. Loom software,
There's the
right?
Loom extension we can make use of.
Oh, okay. Yeah, that's awesome.
And that's what I was asking, because for the Loom now, I have to present the screen before I can record myself on Loom, right? Or is there a way we can use Loom to just my FaceTime and I'm talking what I need to say?
Yes, so the most straightforward answer is you can use your phone camera and record yourself. You don't need to record any slide. Just show your face talking about challenges in layer 1 and layer 2 blockchain solutions. So that's all. So just a video recording of yourself talking about layer 1 and layer 2 blockchain solution. You can have a script, but just make sure that you are in the video. Any other question? Any other question before we call it a day? So we'll be ending the call by 11:30. So if you still have any question, you can drop it on the WhatsApp group or you can drop it in the message box. Yeah, you can edit it professionally. The better the quality, the higher the score. So that's it. Yeah, and when I okay. Okay, so what I mean about quality, it doesn't have to be like the camera quality alone. It's about the quality of what you discussed in the video. So that's it. Doesn't have to, and also your audio. Yeah, just make sure that it's audible and it's clear enough. So that's it. Yeah, so someone said we don't do video edit and blockchain. Yeah, the quality of the message is what matters most, and so it's just for accountability, just to make sure that you guys are, you know, learning and also trying to, the best way to learn is when you teach. So by providing this 2 minute video, that shows that you can actually teach someone and you know what you are saying. So that's it. Yeah, you can go as you can edit, you can use animation. Yes, it's up to you. It's up to you. But the quality of the message is what matters most here. Yes, and also at least you can't use AI to complete this kind of assignment. What do you think about that? If you check the board now, you can see that most people are actually using AI to complete the assignment. So I'm still looking forward to how creative you can be to use AI to create this kind of video. So let's see what So so there will be evidence that you're actually learning. Because I've been seeing people using AI. There's 99% AI, 100% AI, 45% AI. So let's see what you guys can do. Maybe you will try to embed your picture into AI and generate videos. And yeah, there are a lot of technologies outside there that can do that, but they are expensive. So and it won't be you. So it's I will know from that all these persons. Yeah. Yeah, I feel like some actually do something like this. You can do text to audio, then overlay it with your picture or your video. Then now you see, let's see how creative you guys can be. So I'll be waiting for your submission. So thank you. That's it now. Like I'm giving you expo, and also at the same time I'm showing you I know how to track you guys and know if you are using AI. So don't worry. Yeah, so we ended the call in the next 2 minutes. So yes. Yeah, and one thing is that once you submit and you get a response, you cannot change. You cannot resubmit again. So you just have just one chance. So once you submit, you cannot edit your submission again once it has been graded. So make sure you are submitting quality assignment. Thank you. We just have 1 more minute to give. If you have any question, you can ask. When is the submission deadline? Friday. Yes. Friday. You can submit by Friday, 11:59 p.m. on Friday. Yeah, deadline is supposed to be Saturday, but since this week you just have Monday to Thursday, so you are free to complete all the assignment by Friday. Yes. Yeah, we have to also grade and give feedback. So that's why. Oh, the lecture is just 12 hours per day. So you can have enough time to complete those assignments. And as I've said before, you don't need to write 1,000 words. Like this week now, we have one assignment. I want to check it up. You have one assignment to discuss limitation of using blockchain technology. Second one is investigate common security vulnerabilities in blockchain. Then also conduct research on Arbitrum sequencer and their importance. Then this one is talk about layer 1 and layer 2 challenges and stuff like that. So if you know how to combine everything together in one article or in one video, you can still take that as submission. So don't worry, we are considerate with everything we are doing. Thank you. So I'll be ending the call now and we can continue on WhatsApp. If you have any question,